In last class, we discussed the conservation of mechanical energy for these rotational bodies, and we have seen what is the work done by the torque and as well as work energy theorem. That is what kinetic energy of a rotational body and as well as work done by the torque in the previous class. Now you can see in last class also we have studied conservation of mechanical energy. So which is long back we studied like I think it's a third chapter. So initial potential energy. So 1 minute. Okay. So we studied conservation of mechanical energy. So we all knows that initial mechanical energy is equals to final mechanical energy. So that is what is always remains. Energy is neither be created nor be destroyed. So it will be transformed from one form to another form. And you have seen that here, when all the forces are, this is applicable only all the forces are, what forces, all of you? They are actually conservative forces. If it is a non-conservative forces, we are not going to apply this one. So with this, after that, we have solved one numerical, which is related like when a rod which is attached to the pivoted point just released, just released. So then we have been calculated what is the work done like angular velocity. So that how much it is been rotated, we have been studied that. I hope you have studied that. Am I right, all of you? So we have got that angular velocity, which is equals to root over 3g by L. So this is what is the derivation we have been made in the last class. So now from there, we are going to continue one more problem, and then we are going to study the most important concept in this entire chapter is angular momentum. So that is the very important concept for NEET and JEE, and as well as that is the most typical concept in entire chapter. So that's what we are going to study today. So every year, definitely there will be a question. So now before that, let us study the one more question related to this this work energy theorem. Now let me take a surface, a frictionless surface. All of you observe, it is a frictionless surface. So frictionless surface means you all knows that, and there is a mass m having a capital M, okay, which is above from the height. Let me take h height, or you can take x meters. You are convenient, whatever you want, you can take. Now you can see there will be a pulley where the pulley is also frictionless pulley, having a moment of inertia I. Frictionless pulley having a moment of inertia is how much? Everybody? I, and having a radius R. Radius of the pulley is R. So this is also a frictionless surface. And you can see, let me take, there is another mass where actually small m, and this is the baseline. So this is the baseline of the system. Now you can see, all of you. So the baseline, this is the baseline means, so we all knows that if it is the baseline, so initial potential energy here what, everybody? Initial
Zero.
potential energy is zero. Okay. So let us consider now what is the question. So as I said, it is a frictionless pulley and as well as surface. That is the first thing you have to remember. Now here the question, understand very carefully. For no slipping, recently I have taught you this one. For no slipping between pulley and rope, between pulley and rope. So in this case, Pradosh, what is the velocity of the pulley and velocity of the rope? Both is remain same or different? No slipping. Be very careful. Recently only I have taught you people. Slipping, if it is a friction, pulley velocity is different, rope velocity is different. If it is no slipping, pulley and rope velocity both is having what? Same. So remember, pulley and rope. So actually it is a massless. Massless. So now they are asking the system is released. The system is released. Okay. Find the velocity of block M. Block M when it has fallen through the height X. When it has fallen through height x. Height x. So that is what it is. We have to find it. So observe very carefully. This is a question. So we can apply here the work energy theorem. So that is what, sorry, conservation of moment, conservation of energy, mechanical energy. So initial mechanical energy is equals to final mechanical energy. Do you understanding everybody, Mr. Udresh? So now this is the baseline. So all of you observe very carefully. Initial potential energy. If this is the baseline, now observe this pulley and mass m is present. How much height above from the baseline? Everybody, yes, please. H. So they are present above. So both they are having some potential energy or not initially. Everybody, this potential energy is mgh. So positive or negative? Above from the baseline. Above from the baseline, positive. Going below, baseline is what? Negative. Understanding? And this pulley is also above from the height h only. They both are in the same. So that what is the pulley? Everybody, let me take mass of the pulley is mp. What is the mass of the pulley? mp. Then what is the momentum? What is the potential energy? Initial potential energy. Everybody, mg, mpgh. Mass of the pulley.
MPGH.
That I can check. So initially, the mass of the capital M potential energy is mgh plus mass of the pulley. Sorry, potential energy of the pulley, which is equals to what? Everybody.
MPGH.
Yeah, mpgh plus what about the mass of this? Sorry, potential energy of this mass. It is at the baseline. What is that? Everybody.
0.
Yes, please. 0. And as well as entire system in rest. Entire system in rest. So means in the sense of kinetic energy is what? Entire system is not released. Kinetic energy is what? Everybody.
0.
0. Clear, everyone? Understand, brothers? Rudresha? Now, it is released. It is released and it is traveled how much meters? Everybody? It is released and it is traveled with how much meters? All of you. Please respond. It is traveled with how much meters? Some x meters they have been given. This is small m and it is traveled down in how many meters, everyone? Some x meters. Are you understanding, everybody? So now they are asking, what is the velocity of this one? So now see, as it is a frictionless surface and as well as massless. So now whatever the velocity of this block is going downwards, let me take v velocity. This capital M also will travel with the same velocity v. Am I right or wrong, everybody? Yes, please. And as it is a frictionless pulley, there is no friction between the pulley and the rope. So now you tell me, rope and pulley is having the same velocity or different velocity? Everybody. Rope velocity and pulley velocity both are having what? Everybody. Same. Do you understand it? So because it is a what actually? It is the frictionless. So no slipping. No slipping is taking place. So when the pulley point, let me take the pulley point A is this one and this is B. If the pulley, A, if the pulley point A is moved from here to here, then rope also move from there to there. It's not that it is slipping. The rope is not slipping over the pulley. Whatever the displacement shown by the pulley, the rope is also the same displacement, each point. That is what is the meaning of no slipping. So both pulley and as well as rope is having the same velocity. So as it is a frictionless surface, velocity of V, this body and this body is same. Now after that, after most released, what is the final potential energy of a pulley? Pulley and this capital M. Anybody? Remains still they are in above height h. So is there any change in the potential energy, Pradosh? After releasing also the capital M is same height and pulley is also same height. So now, what is the potential energy after releasing? Still it is mgh and pulley potential energy also how much? Pulley potential energy also mp. But potential energy of this mass, small mass. What is the potential energy of a small mass? You see from the baseline it is went down. Down it is went. So it is minus xa plus xa. Everybody. Minus. How much it is? Minus mgx. Are you clear? Will you all agree with me? Everybody?
Yes, sir.
Plus, what about the kinetic energy? Final kinetic energy. What is the kinetic energy of this one? Capital M, kinetic energy. Half mv square. What is the kinetic energy of this body? Half mv square. Now this pulley is rotating. What is the kinetic energy of a pulley? Rotational motion. Fastly, every day from long back we are studying the same thing. Rotational motion. So that what is the kinetic energy of a pulley? Pulley is rotating, Ra. What is the kinetic energy? Half I omega square. Half I
Omega square.
omega square. So kinetic and final kinetic energy of the capital M is half mv square plus kinetic energy of the small m is half m small m v square plus kinetic energy of the rotational pulley is how much? Everybody, half I
Omega square.
Now see everybody. So very important. So potential energies remains constant, so that all will get cancelled. This minus mgx will come this side, will become plus mgx. So plus mgx is equals to half into mv square plus half into small mv square plus half into I omega square. I omega square. Till here, any doubt? Anybody can ask. Clear? Understand everybody?
Yes, sir.
Yes. Now, so we all know that. Can you tell me what is the relationship between V and R and omega? V and omega. V and angular velocity and velocity relation. V is equals to everybody. V is equals to no use
R
omega. Because we all know the acceleration is equals to R alpha.
R alpha.
Is equals to R theta. We all know or don't know? Knows that.
Yes, sir.
Omega is equals to, can I write V by R? Everybody? Yes, please respond.
Yes, sir.
In this all three, 1 by 2 is common. So 1 by 2, if I write this side, so it will become what? 2 mgx. Clear? So 2 mgx. So what is remaining? mv square plus mv square plus I into omega. In place of omega, what I can write? Everybody?
V
by R whole square. So which is equals to, okay, mv square plus I v square by R square. So in this one is common. Can you tell me what is the common? V square is V square common I will take. So what is remaining? Capital M plus small m plus I divided by R square. So which is equals to 2 mgx. So they are asking V. So we want V square or V. So V square is equals to 2 mgx divided by capital M plus small m plus I divided by R square. So V is equals to root over 2 mgx divided by capital M plus small m plus I divided by R square. This is the velocity formula when the pulley is like, when the frictionless surface, when the mass is sliding down. I hope you all understanding. So it's very simple. So now see, again I'll say you, initially that capital M and pulley is above height h, so that they are having a potential energy. One is mgh and this is mass of the pulley is mp. So mpgh. Okay, p you write in the subscript. Then this is a baseline. So baseline means what is the potential energy of a small m? Everybody, what is the potential energy of a small m? 0. Understanding? So that is what. So only these two bodies is above from the height h. So I have written that. Next, kinetic energy. Initial kinetic energy is what? System is not released. So that entire kinetic energy is what? Initial kinetic energy. Everybody. Initial kinetic energy become 0. So there is no change in that. So that is you should understand. Then what will happen? Which is equals to final kinetic energy. After releasing, still the capital M and the pulley is above height h. So their potential energy remains same. But this mass is released and it is traveled a how much distance? Through the height x meters. Yes. So it is released to travel x meters. So it is going below, down to the baseline. So it is potential energy is minus mgx plus what is the kinetic energy? All three bodies are released. So released means all three bodies will possess the kinetic energy. What is the kinetic energy of this? As it is a frictionless surface, velocities of these bodies remains constant. Mr. Murali, understanding? So velocities of these bodies remains constant. And here they mentioned that pulley and a rope is a what actually? It is actually no slipping. So no slipping. What do you mean by no slipping, everybody? Last 2 days before I have taught you. Just check your classworks. So remember, if it is a slipping means pulley velocity is different, rope velocity is different. To understand everybody? If it is no slipping means, suppose I choose the point A in the rope and the pulley. Then if a point is traveled to up to this point, so whatever the pulley displaces, then rope is also displaces the same thing. That is what is the meaning of no slipping. So the velocity of the pulley and velocity of the rope, both is remains what? Everybody? Same velocity. Clear, everybody? It is the same velocity when they are no slipping. That is what is the main thing. So if you have taken that, what will happen, everybody? So kinetic energy of a capital M is half mv square. Kinetic energy of a pulley is half small m, sorry, pulley not this m. Yeah, pulley is a small mp here. So that is, you have to remember it. So small mp v square. mp, a small m means what here? So correct only. Small m, not mp. Small m v square, this pulley. And this pulley what? Sorry, this mass. Pulley what? It is actually rotational motion. So rotational motion means what is the kinetic energy? Half I
omega.
So that's all it is. Now you can get cancel everything and you will get it. What is the velocity is equals to root over 2 mgx divided by m plus capital M plus small m plus I divided by r square. That is what you have to remember. Are you clear, everyone? Yes?
Yes, sir.
Please solve. Naren, understand, Naren? Pradeep, Sai Karthik?
Sir.
Call to the Rishi, what happened to him? Understand now? Everybody, you have to solve. If not solving, then noise. Clear, everyone? Once it is completed, only we'll
Yes,
proceed.
sir.
Okay, shall we proceed now?
Yes, sir.
Yeah. So now we'll go with the next concept. So that is what is very important concept. So angular momentum. So the next concept is angular moment of a point mass, of a rotating rigid body, of a rolling body. So one by one we'll discuss. So first we will see now point mass. There is only most important one. So even small doubt also, please you ask me. Okay. So write it. Next concept we are going to study angular momentum of a point mass. Okay, that's all is our things. Later we'll study of a rotating rigid body and a rolling body. Okay, that all we'll discuss it now. So this is NEET. Every year minimum one question will be there in this three parts, like point mass, a rotating rigid body, a rolling body. So JEE mains, we can always expect a question, and NEET 100% they will ask the question related to this angular momentum of a point mass. Now let us take what do you mean by angular moment of point mass. Before going to study that, moment of force we used to call something. Can anybody tell me? Everybody? Moment of force we used to call something. Yes, Mr. Udreswa? Narayan? We have studied already. Moment of force is called something. Anyone? That is only called as torque. Understanding, everybody? So torque is equals to, what is the formula, everyone? R into F. Yes or no? Everyone? So same way, angular momentum means movement of momentum. That is the meaning of angular momentum. What do you mean by angular momentum, everybody? Movement of momentum is only called as angular momentum. So what does it mean? You can see, all of you observe, see many things you can find it here. So moment of force means, as we all know, the torque, tau. Same way, moment of momentum is called as angular momentum. So moment of force means what? R into F. Same way, moment of momentum means R cross. What is the momentum symbol? 9th class also you studied, 10th class, 11th also I taught you. Momentum symbol, everybody. Yes, P. What do you mean by momentum? Mass into
Velocity.
velocity. So, R cross P, that is only called as angular momentum. Moment of momentum is called as angular momentum. The angular momentum symbol is L, or many books you can see, they will notice with the J also. So you are convenient, whatever you want, you can, but L is very standard one. So L is equals to R cross P. This is only called as angular momentum. Anybody having any doubt, you can ask me. Clear, everybody? And you can see, so as it is P, momentum is a vector quantity. This is what momentum? Linear momentum. Linear momentum, not angular momentum. So it is a linear momentum. P is equals to M cross V, mass into velocity. So this is a vector quantity. So linear angular momentum is also what quantity? Everybody? It is the vector quantity. That is what you have to remember. Now, let us see this one I can replace. As we know, momentum means mass into velocity. So I will replace L is equals to R cross, what do you mean by momentum? Momentum means what? M into V. Clear, everyone? So I will take M. M is a vector quantity, sorry, scalar quantity, does not depend on anything. So I will write mass into R cross V. Is there any problem for anybody? Everyone? Are you understanding, everyone? So A into BC, I will write as a B into A, B dot A cross C. Can I write it or not? Everybody? Yes, please.
Yes, sir.
So that is only the angular momentum formula. Angular momentum is equals to M into R cross V. So this is one of the formula. Let us comes to the units. So what is the units of this one? So we all knows that. What is the units of mass? Everybody? Let me take it whatever it is. So what is the units of momentum? What is the units of mass? Everybody? Kg. What is the unit of R? Meters. What is the unit of velocity? Meter per second. So units of this one is kilogram meter square per second. This is the units of angular momentum. Remember, momentum units is mass into velocity. So mass unit is kilogram, velocity unit is meter per second. 9th class also you studied. Now it's angular momentum. It's not momentum. Angular momentum unit is kilogram meter per second square. I hope you all understand. Anything doubt you can ask. Clear, everybody? Rudresh?
Yes, sir.
Yeah. Kadri? Understood? Pradeep?
Yes, sir.
Yeah.
Yes,
So
sir.
that is what you have to understand. Manya and Samya solving or not? Sai Karthik, Rohit?
Yes, sir.
Do it. So now you can see. So we are going to study now. Let me take. So what is our today's concept? Angular moment of a point mass. So it's not a rigid body or some other thing. So just a point mass. So let me take, there is a point mass inside a system. So I will take that. That is a point. Let me take O, comma O. That is what R is. So somewhere the point is located. This is the point mass whose mass is M. What is the mass of the point? Everybody? Whose mass is M, and which is present from the origin. That is what, from the pivoted point, having a distance R. Having a distance is how much? R. Are you clear? This is what R. Now this particle velocity is V. Particle velocity is what? Everybody? V. Clear? Now it is making an angle theta, angular displacement theta. Now, what is the angular momentum about this particular point? About this, which point? This small m point. Which point? This point. What is the angular momentum? We have to find it. So, let's start now, everybody. All of you. You can take any mass. What is the angular momentum about this point? That is what. So, we all know that angular momentum formula is what? L is equals to R cross P. So we all know that R cross P means what, everybody? Mass into everyone. Yes, please respond. Mass into velocity. Understanding? Now I will write it. So mass is remains. So I will take R cross V. Now can you tell me R cross V? It is a cross product or dot product? Everybody? Cross product or dot product? It is the cross product. So cross product, we have been done something. You have just revise everything and tell me. Remember, cross product means sin theta or cos theta. Yes, Mr. Pradosh. Sir. Dot product and cross product. Cross product and dot product. What is it will come? Cross product means cross product of AB. What is the formula? Cross product of AB, we can say what? AB cross product of R into V is actually M into R into V sine theta. So remember cross product will come what? Sine theta or cos theta? Not
Sine theta.
remember. Sine theta. So cross product of AB is actually what? AB sine theta. So same way, cross product of R into V is RV sine theta. And this one, can I write it as a M into V R sine theta. So why I'm writing R sine theta, you will understand it. So we have to find the momentum. So angular momentum about this point R, about this point of point mass M. So all of you observe very carefully. Let me draw now. So you have to find the direction of angular momentum also here. So for finding the angular momentum direction, so I will I'll make you. So again the same thing, we'll apply right hand thumb rule. So let me take, this is the point. If you observe, if I draw a baseline parallel, you can see which is passing through the horizon. That is what pivoted point. So this is parallel to something. What is that, everybody? Parallel to velocity. Am I right or wrong, all of you? Yes, please respond. Yes.
Yes,
So
sir.
now, then here is the theta, means here also what is the angle? Everybody. Here also angle is what? Theta. Understanding? Now then here what will happen? This will become R cos theta, and perpendicular it will become what? Everybody. R
Sine theta.
means perpendicular means parallel shift if I make it here. So this is what is we used to called as R sin theta. Am I right or wrong, all of you? Yes, please.
Yes, sir.
Yes. So now this R sin theta is what actually? R sin theta is perpendicular to R. That is the meaning of it. Am I right or wrong, everybody? Yes, please. So in place of R sin theta is what actually? We can say momentum is equals to R into F cos theta. We can say it as a R into F perpendicular. Am I right or wrong, everybody? Yes, please. So we can say R sin theta means, can I say it as a MV? What is that? R sin theta means what? R sin theta is what actually? It is perpendicular to R. Do you understand, everybody? So that is the R sin theta. So this is the most valid formula. 95% cases, angular momentum of a particular mass M of a system, MV R perpendicular. That R perpendicular means what, everybody? R sin theta. So how it will be? Let us see that now. So you can see, for finding the direction of angular momentum at this point, all of you apply right hand thumb rule or screw rule. So you are all very familiar with that. So I'm applying right hand thumb rule now. So please apply right hand thumb rule at the point. You move from R cross V. R cross V, right hand thumb rule you apply and you tell me cross it is. It is a cross. Cross means it will come inwards, outwards. I told you recently also. Dot means outwards. Cross means what, everybody? Cross means what? Inwards. Now, all of you put your fingers here. Put your fingers here and come from R cross V. Tell me, everybody, R cross V, what it is that? It is, what is the direction of the thumb? Direction of a thumb is inwards or outwards. That is what is I want. Either the right hand thumb rule or screw rule you apply. You apply screw rule or right hand thumb rule and you tell me R cross R cross V you are moving. So if you are moving R cross V, so please tell me what is the direction of your thumb? Either it is inwards or outwards. You are moving clockwise. Clockwise you are moving. So it is inwards or outwards, everybody? R cross V, if you move, it is a clockwise. So that it is a what? Inwards or outwards, everybody?
Inwards.
Inwards. So R cross V, if it is anti-clockwise, it is a what actually? Outwards. Understanding, everybody? So please put your fingers, put your hand here, right hand thumb rule. Move your four fingers from R to V. R to V. Then you tell me your thumb is acting into the plane or out of the plane. Everybody. This is your plane. R cross V is your plane. Your notebook you draw. You imagine you are moving your hand from R cross V. So that your thumb is acting into the plane or out of the plane. Everybody. Yes, please. Respond, Ra. You can see that. You can experience it only. You can tell me. If not, I will make it. Now you can notice I'm sending the video. So imagine that if this is the plane, just I'm sending the video, you can watch. So this is the R and this is the V. So if I'm moving from R to V, if I'm moving, my thumb is acting into the bench. So into the bench means that is inwards because it is a clockwise. Clockwise means it is inwards. All of you watch that video and then only you can do it. All of you make it. So you are getting or not, you can tell me. So either what is the direction? If you want to find the direction of angular momentum, so what we have to do, guys? We have to apply which rule? Right hand thumb rule, or we can apply what? Screw rule. Understanding? So if you move the screw from R to V, you can see R to V, if you make the screw, so that the screw will go into the plane. Into the plane, you can watch. Watch the video and tell me, all of you. So for finding the direction of angular momentum, you have to apply which rule, everybody? Right hand thumb rule, or we can say screw rule. If it will move from R to V, it is clockwise means it is inwards. R to V, if it is anti-clockwise means it is outwards. Please make sure everybody, if it is completed only, then only you can proceed. Everybody, watch the video and tell me. Any doubt? You can ask. Clear? And R cross theta. Cross product means remember AB sin theta it is. A cross B means AB sin theta. So R cross V means RV sin theta. So I'm writing M into V separately. I'm writing R sin theta. So R sin theta is actually what? R sin theta is actually what? R perpendicular. R perpendicular, which is equals to R sin theta. So I'm replacing R sin theta is equals to R perpendicular. So will become, what is the angular momentum formula? MVR perpendicular. That is what you have to remember. Are you clear, everyone? Please respond. So always if you take R cross P, what is the angular momentum direction? Verify it now. Just now I said R cross P, if you verify, what is the direction always? It is perpendicular or parallel to the surface? Everybody. R cross P, the direction of the thumb is always perpendicularly to the surface. That is you have to remember. If you take any two things, if you are doing the cross, the resultant vector will get always perpendicular to the surface. If I do R cross P, so that the angular momentum will come always how, guys? Perpendicular to the plane. So R and P are one surface. Always the perpendicular to this surface, the angular momentum will act. That is what you have to remember. Have you watched the video? Everybody, just watch and then we'll proceed. Are you clear?
Yes, sir.
Yes, parallel shift I am using. So R sin theta is actually perpendicular to perpendicular to R. That is what is actually it is. So always remember, for finding the direction, one more thing I am saying you. For finding the direction of angular momentum, all of you remember, for a particular particle, this is big angle and this is what angle? This is a bigger angle. Big angle, and this is what angle, everybody? Small angle. So always you have to move your right hand thumb rule. Right hand from only small angle, not big angle. So it is clockwise or anti-clockwise? R cross V. R cross V is a small clockwise or anti-clockwise? It is clockwise. So clockwise is your thumb is acting inwards or outwards? Direction.
Inwards.
Inwards. So you can see this is your plane, X and Y axis plane, so that it is acting into the plane. That is what always perpendicular. So R cross P, which is equals to L, is always perpendicular to this plane. That is what you have to remember. I hope you all understand, everybody. Anything doubt, you can ask. Clear, understand, everybody? Yes?
Yes,
All of you? Yeah. Now you can take in this formula. So this is the original formula where always 95% cases, this will be the true always. Now let us take one more thing. So now instead of this one, I will go with V actually. V. So R is always perpendicular to V. V is always perpendicular to R. So I will say now you can see this is the R of a particle. This is now which is V actually. V is this one. So having a theta angle. Now theta angle means here what will happen, everybody? In form of V, you tell me. This will become what? V cos theta. Am I right or wrong? Yes, please respond. V cos theta. This is the resultant one. If this is the resultant means, yes, Rudreswar, tell me. If this is the resultant means, this will become what? Everybody. If here is the theta, this will become what? V cos theta. And perpendicular to this, it will become what? Everybody. V sin theta. Do you understand, everybody? So that is what it is. So it is V sin theta. It will become V sin theta. And here, what is the angle? Both R and V are what? Perpendicular to each other. Both are perpendicular. Perpendicular means how much is the angle? Everybody? Yes, 90 degrees. So I will modify the formula. So MVR sin theta. Now I will write as a MRV sin theta. Before I have written what? MVR sin theta, so that MVR perpendicular. Now I am writing MRV sin theta. So V sin theta is actually what? V sin theta is actually what? Perpendicular, V perpendicular to R. That is the meaning of it. So I will write in place of V sin theta. What I can write? MR, everybody. V sin theta means what? V perpendicular. But this is very rarely only it will be. So most of the cases, which is always true, MVR perpendicular. That is what you have to remember. So R sin theta is always, R is actually what? It is actually perpendicular to V. How much it is angle? 90. Perpendicular to V. R perpendicular only equals to what, guys? R sin theta. Understand, Rudreswar?
Yes, sir.
Yes. Now we are making in the form of V. V is not perpendicular to R. But who is that? V is having theta angle means it will become what? This will become V cos theta. And another resultant force this side will become what? V sin theta. This V sin theta is perpendicular to what? R. So that is what? V perpendicular we write it. Are you clear, everybody? Understand, all of you? So this is what is about angular momentum about a particular particle of angular momentum of a particular particle. So very, very important. So what is the formula, everybody? Meeting is going to end. Please join back fastly. So angular momentum of a point mass. What is the formula, everybody? L is equals to MVR perpendicular. So it is clockwise. Always apply right hand thumb rule. If it is a clockwise, inwards, anti-clockwise, outwards. So that is very important one. Okay.